In the percent chloride experiment, we determined the percent by mass of chloride in an unknown sample. And we used volumetric analysis to do that. Before we start getting into the math, let's just kind of do a little bit of a reminder about how the reaction worked. Okay, this is the net ionic equation. Silver ions are combining with chloride ions to make a precipitate, silver chloride. The silver ions were in our burette. So this tube is a burette. Sometimes it's spelled with an E-T-T-E, but in our lab manual it's just E-T. So the burette is the glassware that allows us to keep track of the solution. And our silver ions were in silver nitrate that is dissolved, so it provided the silver ions. Our chloride was down here. We took our white sample, and the sample is just a salt. It is not pure chloride. It's not supposed to be. It has to be like sodium chloride or potassium chloride or lithium chloride. We don't know what the cation is. We're interested in the chloride ions that are in it. Okay, and we just dripped this down until all of the chloride had reacted. At that point, any additional silver reacts with the indicator, the potassium chromate, and we get a color change. But anyway, the net ionic equation is really simple because it's a 1-to-1-to-1 mole ratio. Okay, let's go look at our problem. Okay, kind of mark some things on here. So we have this is our mass of our unknown sample. And we're trying to determine the percent chloride that is. So you can think of this as being like the total sample, the total mass of the sample, and we want to know like what percent of these grams comes from chloride. Okay, what else do we have? Here we have some water. This you can ignore. The amount of water doesn't matter because the water is not reacting. The amount of the indicator doesn't matter, but you should know what the indicator is. So this is our indicator. And its purpose is that it gives us a color change as soon as all of the chloride is gone. Any additional silver reacts with this chromate, and it gives us the color change at the end of the experiment where it went from lemon yellow to kind of orangish color. Okay, what else do we have? We have a concentration of our silver nitrate. That's really important. We'll use that in our math. And here we talk about the burette. There it is spelled the other way. For the burette, we'll have a before and after, and that those amounts refer to the silver nitrate solution. That's what you'll use that for. Okay, so the net ionic equation, I already told you, you need to know this net ionic equation. Okay, and that's a precipitate. These are both aqueous. Next, I'm going to determine the moles of silver nitrate. And so first I need to see what volume of silver nitrate I used. And so to do that, I'm going to look at, this is what's in the burette, is the silver nitrate. So I'm going to look at those readings and I'm going to basically subtract. So it's 15.42 milliliters final on the burette after the reaction minus the initial Okay, and again, these are from the burette readings, the final minus the initial. So once I know what volume of silver nitrate I used or reacted, then I can use the concentration to get to the moles. So let's look at how I would do this. So 15.40 milliliters of that solution. And to get to moles, I need to use the molarity. And the thing is, this molarity up here, that's in moles per liter. Moles per liter. So I need to get to liters before I can use that. So I'm going to do a little step here to get to liters. And then once I'm to liters, I can go to moles of the solution. And that is using the molarity above. So this step is where I use that molarity. Of the solution. And then I'll get a moles. And it's going to be a really small number. Let me get this out of the way. Okay. And once I have that, then I also have the moles of silver ions, and I can see that that is the same number because every silver nitrate has one silver. So this is the same number. And guess what? That is the same number as the number of chloride ions, or the moles of chloride ions. And I really should put moles in there. Those are all in moles. So now I know how many chloride ions were in my sample. So let's go back over here. So I know how many chloride ions were in my sample. It was 8.07. And if I want to know the mass, just like any other time I want to go from moles to grams, I usually use a molar mass. So in this case, use the periodic table to get the molar mass for chlorine. Treat it the same as if it were just chlorine. Okay, and that gives me my mass of chloride ions that were in my original sample that I dissolved in my water. So now when I want to get my percent by mass, I use the amount, the mass of the chloride divided by the mass of the whole sample. And that's what I originally dissolved in my water at the beginning. So this will be a given number. You won't calculate it. You started off with an unknown white powder that is it could be a mixture of chloride salts, and we're trying to figure out what percent by mass it is chloride. So we do that. And that's it.